In the previous video, we learned about the trigonometric form of a complex number and how to convert back and forth between the standard form and the trigonometric form. Just to remind you what that meant, if you have the standard form a plus bi, we can rewrite this as r cis theta, and that corresponds to r cosine theta plus I times sine theta. And this all came down to looking at the picture where you have the triangle where a plus bi means you go right a and up b. And now we're looking instead at the distance along the edge, the magnitude r, and the angle that it forms with the x-axis, theta. Okay, so we learned how to convert those, but we said that we were going to see in a later video what good that is, and now we're going to see it right here. Because it turns out that if you want to multiply complex numbers that are in trigonometric form, and let's say you have r sine theta as one of these numbers, sorry, not sine, cis theta. If you have r cis theta as one complex number, and I need another one here, let's say t cis alpha, just to give a different complex number, then it turns out the answer, when you multiply them, you just multiply the front numbers, r times t, and then you add the two angles together, cis theta plus alpha. Now you can prove that this is true if you really want to. You would say, okay, what happens if you have cosine alpha plus I sine alpha, sorry, theta times cosine alpha plus I sine alpha. So you would multiply this whole thing out, you get a big long mess, and then you use the sum of angles identities that we learned back in a previous chapter. And it turns out that when you do all this and you simplify everything, it ends up becoming cosine of theta plus alpha plus I sine theta plus alpha. So it works out just perfectly when you FOIL these to just be the cosine sine of the sum of the two angles. And this makes multiplying complex numbers really easy. We don't have to try to do a foiling anymore. If I give you the number 5 CIS 30 and I multiply that times 3 CIS 20, then I don't have to do any foiling. I don't have to do I squared is negative 1. I just know the answer now is going to be 15 CIS 50 degrees. So we go ahead and we just multiply the front numbers, add the angles, and we can multiply two complex numbers very fast. On the other hand, if I want to divide complex numbers using trigonometric form, if I want to divide them here, it's very similar. So let's say I have r cis theta divided by t cis alpha. It turns out you just divide the front numbers and do CIS of the top angle minus the bottom angle. So let's say I wanted to do 5 CIS 30 degrees divided by 3 CIS 20 degrees. I'd have 5/3 as my new magnitude here, and then CIS, and it'd be 30 degrees minus 20 degrees is 5/3 CIS 10 degrees. And so again, when you have things in trigonometric form, it makes multiplying and dividing them very easy. Whereas before, when you multiply, and especially when you divided, you had a whole bunch of extra work to do to solve them, but trigonometric form makes it go fast. This is one of the biggest benefits to the trigonometric form, is to be able to multiply and divide complex numbers quickly. In fact, there's a whole theorem based on this property. And this is called de Moivre's theorem. And what de Moivre's theorem tells us is that if you want to take a power of a trigonometric form complex number, all you have to do is raise the front number to the power and multiply the angle by that power. So this works if you want to say square a number. You just square the magnitude and double the angle. If you want to raise a complex number to the 10th power, you just take the front number to the 10th power and multiply the angle times 10. If you want to raise a complex number to, say, the 100th power, just take the front number to 100th power and multiply the angle times 100. Now, think about how you would do this with a regular complex number in standard form, say 5 plus 3i to the 100th power. That would be insane to try to calculate, right? You have to write it out 100 times, do a whole bunch of foiling, and maybe come back the next day and eventually you'll be done with the work there. It's insane. Whereas if you have written in trigonometric form, you just take the front number to the power 100, then you take the angle, multiply it by 100, and you have your answer to the final problem. Now, as a starting example here, I said we're going to find the quantity 1 plus I cubed. Now, I could have made it to a higher power. Maybe it's not worth it. If all you're doing is to cube, you can write it out 3 times. But we're just trying to get the idea down here more than trying to do a complicated calculation. Notice that it's right now written in standard form, but to use de Moivre's theorem, we need to change it into trigonometric form. So I need to figure out what is my r and what is my theta for the complex number 1 plus I. And we can go ahead and draw our triangle here. It's 1 to the right plus 1i up. So in fact, this is a well-known triangle with 1 and 1 there. The hypotenuse is root 2, and this is a 45-degree angle. So that means 1 plus I is going to be square root 2 CIS 45 degrees. Now that I have that, I'm going to raise it to a higher power. Square root 2 CIS 45 raised to the 3rd power here. That means you're going to cube the number in front, and you're going to multiply the angle times 3. Well, square root 2 times square root 2 times square root 2 is 2 square root 2. And if you do 3 times 45 degrees, that's going to be 135 degrees. And this right here would be a perfectly fine final answer. However, if you don't like that, we can go ahead and actually work out what it is in standard form. So CIS means cosine of 135 plus I sine of 135. And then we use our unit circle. Cosine of 135 is negative root 2 over 2. And sine of 135 is positive root 2 over 2. And then if you distribute this in, 2 root 2 times negative root 2 over 2. 2's cancel. Root 2 times 2 is a negative 2. And then the same thing there, 2's cancel, root 2 times 2 is 2i. And so it turns out that 1 plus I to the 3rd power is negative 2 plus 2i. But again, it would have been perfectly fine to leave your answer as 2 root 2 CIS 135 degrees, unless they specifically want you to have the standard form as your final answer. So the whole point of this is just to show you the tool, the power that we have when we can just take a number, rewrite it in trigonometric form, and then take whatever power we want without having to do a whole bunch of foiling out big, long expressions.